For some more rules. Okay, now you're going to find out that actually this whole chapter is rules, but in a positive way. These are ways to get derivatives without using limits. Keep that in mind. Without using limits, we're doing the derivative. So we had like a polynomial rule. Basically, you can do the derivative of each term. Okay, that was kind of like this little intro problem. That's a polynomial. Then we have a product rule. That's how you do the derivative when you have a product. So now what? What if you have a division problem? We call it a quotient. What if we have a division problem? Well, we need to have a quotient rule. Now, I always like to tell students, because I'd love if you don't do this. Most kids don't, so don't do this like on a test. If I give you a fraction, don't do the derivative of the numerator and denominator. That is not the quotient rule. Okay, again, if I give you a fraction, don't do the derivative of the numerator and denominator. You're kind of like making up calculus. But if you use the quotient rule, it obviously is going to involve the numerator and denominator. Okay, but it involves it like this. Again, are you kind of warming up a little bit to the UV notation? U is the numerator, V is the denominator. So it turns out that you'll do V times the derivative of U. So we call it V du dx. It would be like the bottom. It would be like the bottom and then the derivative of the top. And then you'll subtract. Can you guess what you'll subtract?
U times the derivative of V.
Good. U times the derivative of V. Now, at this point, you should kind of feel like, yeah, it's kind of like the quotient rule. You're sort of like mixing both combinations together. There is a subtraction sign. And there's one more sign. There's a division sign. So it's all over V squared. Now listen, some of the rules that we learned in this chapter, like I'll prove them to you. This is not going to be one of them. Kind of like, where did this come from? We're honestly just saying that it works. But if I was going to prove this to you, we'd have to end up doing a limit as h approaches 0. It would be a little bit beyond the scope of this class. But the quotient rule does work. Most of the time, this little jingle will go through your head. That's what you'll hear me say. And most likely, if you're actually saying it, you'll probably say the same thing. Bottom, derivative of top, minus top, derivative of bottom, all over the bottom square. So we got x cubed plus 3x all over x squared. Okay. Usually these stick out like a sore thumb. I mean, again, it's a quotient. It's a fraction. It's got a top. It's got a bottom. So we're going to use the quotient rule. Okay, so we got x cubed plus 3x all over x squared. Okay, now don't write this down, but just to give an example to what I said to don't do. Again, maybe don't even look, because I don't want you to even think like this. But if you happen to just do the derivative of the top and the derivative of the bottom, and you're kind of like, something doesn't seem right. Yeah, it's not right. That's not, you're making up a rule. Okay, but we will end up doing the derivatives of the top and bottom, just mixing them into that formula. Okay, so the bottom is x squared, bottom derivative of the top. Okay, so you will do the derivative of the top. Make sure you bring the exponent down, so you get 3x, subtract, you get x squared, and then the derivative of 3x is just 3. Minus the top, so we just kind of copy down the top. So minus the top, x cubed plus 3x, times the derivative of the bottom. And the derivative of x squared, we've seen many times, is 2x. And then it's all over the bottom square. Now, I did this on purpose, just right away. Sometimes students forget because they see x squared, it's already squared, so we forget the square. It's x squared squared. It's always over the bottom square. Okay, a little more to it. You basically create a fraction that you better get into it and see if it needs simplified. So, doing the distributive properties, simplifying this. A lot of algebra can be calculus, or a lot of calculus can be algebra as you get into simplifying problems. But remember, you're adding the exponents. And just to kind of save a second here, yeah, you're going to distribute this 2x, but you're also going to distribute this subtraction sign. And I just know it's that subtraction sign right there that is sometimes forgotten. So don't forget to distribute the subtraction sign. Make sure you realize why I'm writing down minus 2x to the fourth as well as minus 6x squared. Okay, again, you're actually, technically here when you do the square, you're actually multiplying the exponents. You're multiplying, but of course you still get 4. All right, and then some combining of x to the fourth, some combining of x squareds, and we get x to the fourth minus 3x squared all over x to the fourth. Now I'm going to say to you that answer is fine. However, algebra would also say that you could. Now before we do that, let me just go back. That answer was fine. But algebra says that you could do the Hart method. If you're saying, well, should I do it or not do it? The x to the fourth cancel nicely to be 1. Okay. The problem here is that the 3x squared, the x squared and the x to the fourth, they don't really get rid of the fraction. They just kind of create a simpler fraction. And so the rule of thumb is unless I can get rid of the entire fraction, you don't need to do the Hart method. But I'll still show it to you. And the real reason I'm showing it to you is because we're going to do this problem without the quotient rule and basically prove to you that you get the same answer. Now, follow me here, because if you're going to do this problem without the quotient rule, that means you have to do something different from the beginning. We have to do something different from the beginning. And it won't be the last time you hear me say this, because I want you to become this kind of student. Sometimes it's better to do calculus before algebra, and sometimes it's better to do algebra before calculus. And sometimes it really doesn't matter. Okay, this was calculus first, algebra second. This is algebra first. Okay, so like the only thing we can do is we can do the Hart method here. Now, again, when you do the Hart method, you're subtracting, you're canceling the exponents. You end up with x. You end up with 3 over x. So again, you end up with x, and you end up with 3 over x. Now if I do the derivative, well, I don't really have a quotient anymore. What I mean is I don't have a top and a bottom, because the derivative of x, well, that's always going to be 1. Interesting. Okay, same one that we got right here. Now, this guy, this will kind of follow us all year. We haven't gone through the year yet, but kids start to realize, okay, Ms. Miller, I get the idea. To do the derivative of 3 over x, you have to think of it as a negative exponent. Okay, the reason being is because now it's a power. Now I can do the power rule. And the power rule says that, of course, you bring the exponent down and all that nice stuff. Now, when you bring the exponent down, you now multiply and get -3. And of course, when you subtract from an already negative exponent, it becomes more negative. See what's happening here? We're getting the same answer. Okay, because by the way, 3x and -2, we don't like negative exponents, so then you flip it back. Okay, and of course that is the exact same answer as what we got over here. Now I want you to kind of look at that and decide which way is easier for you, because eventually there'll be a time where you can just do what you want to do. Right now, you want to be able to do it both ways, because in your assignment, kind of like what happened before the bell rang, there's going to be a question that says, do calculus before algebra, and then it's going to say, and then do algebra before calculus. It basically means do it both ways. Okay, and that's the idea. You do it both ways and you get the same answer. Santa Claus does calculus. Yep, Santa Claus does calculus. He specializes in the quotient rule. If you think of a quotient, if you think of a fraction as a high for the numerator and a ho for the denominator, and you get Santa Claus's version of the quotient rule. Okay, now before I show this to you, I can't take credit for this. I didn't make this up, but it is kind of something silly, and a lot of students use it. So just give it a chance. If you're too cool for school, you might not use it, but it actually is a really fun way to memorize the quotient rule. It goes like this: ho-de hi minus hi-de ho all over ho-ho. Ho-de hi minus hi-de ho all over ho-ho. Now, what is that? Okay, well, it's the quotient rule, because ho is the denominator, so it's like bottom, and then d stands for derivative, so bottom derivative of the top, ho d hi, bottom derivative of the top, minus hi d ho, top derivative of the bottom, and then you get the ho ho. Okay, so whether you want to think of it with the ho d hi minus hi d ho over ho ho, or if you kind of want to just think of it the other way, it doesn't really matter. It's the same quotient rule. We're going to do one more problem. It's got a little bit of like language to it. Find the point where slope is equal to 0. Find the point where the slope is equal to 0, and then we have our function. Now, this is also like a pretty popular problem. Okay, you say, what's so popular about it? A slope equaling 0. That's going to be big stuff. Okay, because when a slope is equal to 0, we're talking about a tangent line that is horizontal. Now, when are tangent lines horizontal? Okay, you've kind of been seeing this. I haven't really announced it yet, but a tangent line is horizontal when your function reaches a minimum. So if your function reaches a minimum, it's a horizontal tangent. Or if your function reaches a maximum. Maximums and minimums are pretty popular. Those are special places on graphs. So this kind of problem also kind of follows us through calculus. Now, to do that, we need the slope. And remember, when I say slope, you say derivative. I guess I didn't teach you guys that little chant yet, did I? And nobody responded. So it's actually a little chant that we're going to use at the next calculus pep rally. It goes like this. When I say derivative, you say slope, derivative,
Slope,
derivative.
slope.
All right. And so derivative, of course, is the same as slope. I'll have to practice that a little bit. We still have some people confused. Why don't you try the quotient rule? Why don't you try the quotient rule? That was kind of why I'm giving you the problem. We'll figure out the whole slope equaling 0 thing. Now, look back at the rule or use Santa Claus's rule. Let's see if you can do the quotient rule. Take a look when you need to. You kind of decide, okay, what I have on the board right now is d high, bottom derivative of the top, minus high d ho. Now, did you get this -1 right here? This is sometimes forgotten, but this -1, that's the derivative of the bottom. That's the derivative of -x. You have to think of it as negative. Okay, so that's the top derivative of the bottom. And then all over ho, all over the bottom square. Is there anything you have a question on with just kind of the following the rule? I hope you're trying to simplify it, so go ahead and see if you can simplify it. Okay, if you're careful about plus and minus signs, it turns out that the only thing that you really can do is combine a -2x squared with a positive x squared. So we get a 2x minus x squared. Now you'll notice that I have not FOILed the denominator. I can't think of a time, that doesn't mean that it never will happen, but I just be honest, I can't think of a time where you FOIL the denominator. It's not common. So just leave it in sort of its factor form. All right. We're going to do the whole slope equaling 0 thing here in a second. Do you have any questions on the quotient rule? Are you sure? Now, we haven't done this yet, but it's not hard to do. You just have to kind of pay attention. It says the slope is equal to 0. That means the derivative is equal to 0. That does not mean that x equals 0. So set the derivative equal to 0. Set the derivative equal to 0 and solve for x. Okay, it's kind of that situation where you're going to set and solve. Now, as soon as you set it equal to 0, you are forcing the slope to equal 0. So whatever x value we find is kind of like our mystery answer here. It's kind of like our point, our place. Okay, now you should kind of be saying to yourself, how do you solve a fraction equal to 0? Well, there's one place that you can't let equal 0, right? You can't let the denominator equal 0. So the denominator is so sad, it's not really part of this. It turns out that the only thing that really can happen is the numerator can equal 0. So it's okay. You kind of take the numerator. You take the numerator and you do a little math. Honestly, the denominator is forgotten because it's not allowed to equal 0. Now, what kind of math do you do? Okay, well, I mean, it's going to happen more than once this year. Whatever math is needed. Maybe you just do a little basic algebra. Maybe you need to pull out a little special tool like factoring. Now, never feel bad if there's something that you forgot or don't remember. We'll try to remind you of it. This is a good situation for factoring because you have a repeated factor. And remember, when you factor it, you're able to then solve each factor equal to 0. You can solve each factor equal to 0. Now, we're almost there, but there's one small problem. We wanted a point. We want a point. Right now, we just have a value. And so Colton would specialize in this. How do you take a value and get it to be a point? Good. Put it back in the original equation. Put it back in the original equation. And put 0 back in the original equation. Well, it doesn't take too long to do that. You end up with 0. Take 2 and put it back in the original equation. Now, just to emphasize, you put it back in the original equation, not back into the derivative. And whether you do that in your head or use a calculator, don't really need a calculator for that, right? But you end up getting the y value. You get the y value. So, I'll try to beat the bell here. Are these 2 points really what they say they are? The original equation was x squared over 1 minus x. Okay, I don't expect you to know what this equation looks like without a calculator. But when you graph it, it turns out that 0, 0 is a minimum because the graph is coming down and then shooting back up. And it turns out, look, even 2, negative 4 is a maximum because the graph is coming down and shooting, or excuse me, it's going up and then shooting back down. So those 2 points are all brought to you by the quotient rule. Quotient rule. Now, you could start your assignment, as I kind of said at the beginning of the period. We will teach a little bit more tomorrow, and I will even teach you section 3 too. So definitely by tomorrow, you're going to want to get working. But you could start it tonight. Never a bad idea just to get started.